Hi everyone, welcome to another episode of K&MRD Radio Stuff. My name is Mike, and if you haven't already, do yourself a favor, hit that subscribe button. Also hit the bell so you're notified when I make new videos. So last weekend was my club's monthly meeting over Zoom, and Kevin from Bioenno Power was kind enough to join us and give a presentation. So I recorded it, and I want to share it with you guys, just in case some of you might not have any clue about lithium iron phosphate batteries. Hopefully this will answer a lot of your questions as to why we might want to use those over any other particular type of battery. So without any further ado, let's get started.
My name is Kevin Zanjani. I am with Bioenno Power. We're a manufacturer of lithium iron phosphate batteries. Some of you may have heard about our company. This presentation is going to be about lithium iron phosphate batteries. So we're going to be discussing kind of the a bit of a background about this technology, as well as how it can be used for ham radio and solar applications. Our company is based in Santa Ana, California, 3657 West McFadden Avenue. We're located near Disneyland, so if you had a chance to come out here to visit, we're just south of Disneyland, about 15 minutes to the south. Website is up there, bioennopower.com, as well as phone numbers. So if you have any questions, you can ask us at the end of the presentation. We're gonna let the questions occur. I'm going to ask them at the end of the presentation just to make it easier because of the format that we have here. So our company was founded in 2010. We're a manufacturer of lithium iron phosphate batteries. So these are batteries that look something like this. They have built-in cylindrical cells. They look something like this that are used to build up these batteries. These batteries are different than lead acid batteries that you probably use for ham radio. This is a new type of technology that offers 2,000 to 3,000 charge cycles. There's a circuit board built into every single battery. They have power pole connectors attached to the battery that plug into your radio equipment, as well as a charge plug as well for charging up the battery. Our facilities are located here in Santa Ana, California, implemented various standards, as well as we're offering a world-class technology, after-sales service, warranty, and we have customers worldwide. In terms of the customers that we're dealing with, some of our customers include those federal agencies, including the DEA. So we do business with DEA. They're using some of our Power Pack products. I'm going to be pulling different products that we're going to show for show and tell. So it looks something like this. These are some of the Power Packs that we do offer. They're using it for powering various tablets out in the field. So tablets and computers out in the field. They're also involved with powering various types of communications equipment as well. DHS is another customer of ours. You're probably familiar with it, is a Raspberry Pi. So not Apple Pie. It's if you're not familiar with a Raspberry Pi, it's a little computer that has a built-in CPU, memory. It has the ability to connect to a lot of equipment. You can use it to control equipment as well. So they're using some of our larger batteries. Something like this is our 20 amp hour lithium iron phosphate battery. It's used for powering various types of Raspberry Pi equipment out there in the field for DHS. DOL, Department of Labor. You might be wondering, why does the Department of Labor use batteries, federal agency like that? Well, they actually handle a lot of the mining industry within the U.S. So out in West Virginia, DOL is using some of our larger 100 amp hour lithium iron phosphate batteries for powering various equipments in mines, because the lead acid batteries, they can't keep up. They've had to change those batteries out every year or so, and they wanted something that can last 2,000 to 3,000 cycles. So about a 7 to 10 year service life versus a steel lead acid or AGM battery that you're familiar with. The Forest Service. So why would a Forest Service be using batteries? It's a very interesting application for the Forest Service. So your federal tax dollars, they go to scientists out in the fields for effectively what it is. It's a very large capacitor strapped onto their back. It's a very interesting application of batteries. I mean, why is a scientist wearing a capacitor on their back? Well, these are scientists that are studying species of fish. They're wearing this fairly large capacitor on the back, using about 6 to 12 amp hour battery to charge up this capacitor. They stick a fairly long rod into fresh water. They send a high electrical current down into the fresh water, and the fish pop out of the water. They measure the weight, the length, just to see how healthy the fish are. And out where you're at, there's a lot of invasive species of fish that are invading the rivers and lakes out there. And so the Forest Service is analyzing these species of fish out there. So it's an interesting application of batteries. Now, this is something called electrofishing. You go on YouTube, you can take a look at it. It's something that you do need a permit. You need to be a federal scientist, I think state scientists as well, qualify for that. But it's not something that you can quickly go and buy. The equipment's sold by a company called ETS Electrofishing out in Waukesha, Wisconsin. Continue to do business with various universities, MIT and Naval Academy as well. They've implemented a lot of curriculum changes, studying batteries, renewable energy, solar products as well, solar equipment that's used out in the field. So that's been implemented in the recent years at the university level. Up in Canada, up near Manitoba, Saskatchewan, Alberta, we do business with companies that are doing oil and gas exploration up there. Despite with all the changes with renewables, they actually use quite a bit of batteries in the oil and gas industry, particularly to power equipment that are used for finding these new sources of oil and gas. And so there's a company called Nanometrics in Ottawa, and we continue to do business with them. They work with a lot of companies up in Canada for oil and gas exploration. The reason they're using the lithium iron phosphate batteries is actually the cold temperature performance. Lead acid batteries can't keep up at very cold temperatures, about minus 30 Celsius, minus 20 Celsius. And so these batteries, they actually hold up quite well, having about over 85% usable capacity versus a lead acid battery, which only about 50% is usable. We're going to talk about more about that later in the presentation. So lithium iron phosphate batteries, several acronyms, LFP, you're going to hear lithium iron phosphate, lithium ferrous phosphate, LiFePO, LiFe. So when we use this acronym, we use this word interchangeably, we're talking about the exact same chemistry. It's now considered to be a state-of-the-art battery chemistry, has a very high degree of thermal and chemical stability because you have a very tight iron phosphate bond. About 2,000 to 3,000 charge cycles. So we introduced the batteries around 2012. We were founded in 2010. We introduced them in 2012. We still have the original batteries out there. It's been about 8 years. We go back to those original OEM customers. We're asking, do you need to change out the batteries? And they say, no, it's still holding up after those several years. Now we want to distinguish this chemistry for something that's used in your phone. So in your phone, like particularly like, for example, this iPhone here, this is a polymer battery, lithium ion polymer, and it's known as LiPo batteries. These are not lithium iron phosphate batteries that's in your phone or laptops. These last maybe about 800 cycles or so, and they use what they call a polymer stack because they can be molded. It's different than this type of chemistry that's packaged in cylindrical cells, okay? So this particular chemistry is packaged in cylindrical cells, something akin to what's in electric vehicles. It's a much more robust in terms of its packaging as well as performance and service life and cycle life. So it's distinguished from batteries that are used in your phone. So what's the difference between, let's compare a lithium iron phosphate battery to lead acid batteries. So all of you've used lead acid batteries. It's in your car. You've probably used a deep cycle lead acid battery for radio, and you found that it's the problem with lead acid batteries. You've probably seen what happened. After they go bad, they sulfate. The acid comes out. I had a problem with my starter battery in my car a couple of years ago. It went bad. The sulfuric acid ate the metal terminals. It actually ate my harness on my car. It was a big mess. This is a different type of chemistry. We're not dealing with any sulfuric acid. We're not dealing with any lead. So non-toxic from that standpoint, and a very tight chemical bond. Lead acid batteries, they're quite heavy. This is about a third the weight of a lead acid battery. So this is a 20 amp hour battery, weighs about 5.5 to 6 pounds. Comparably, a lead acid battery about 18 to 20 pounds in that regards. SLA batteries, maybe about 200 to 300 charge cycles. This is 2,000 to 3,000. So this is a huge difference in terms of cycle life versus a lead acid battery. So as we're talking about in terms of longevity and performance, we're seeing already in year 8 customers that are still using the original batteries in terms of that performance. Some of you may have used a lead acid battery for running ham radio equipment or other types of electronics equipment. You've left the battery, you left your equipment turned on, and the battery's voltage keeps dropping. You get to a voltage where you can't recharge it. You killed the lead acid battery, and it's very hard to revive it. There's no notion of any kind of protection circuitry inside the battery. Every single one of our lithium iron phosphate batteries, they have a circuit board built in. This circuit board provides a protection against overcharge, over discharge, over current, under voltage, over voltage, and thermal protection. So that's built into every single battery, which is really important if you're running your equipment. Let's say you leave your equipment turned on, the circuit board will shut off the output at around 10 volts. So the battery's protected, but from a user standpoint, you'll see a battery that's turned off. So all of the cells that are used inside the lithium iron phosphate battery, they're sitting at voltage, but the output's been turned off. Another important aspect is the fact that with a lead acid battery, there's something known as the Puchert's effect, where only about 50% of the battery's capacity, lead acid batteries, is usable if you were to pull what's called a 1C discharge. So for example, if I was pulling, for example, on a lead acid battery, a 20 amp hour battery, or 12, I was pulling 20 amps out of it, only 50% usable. But with a lithium battery, I can get nearly 100% usable capacity out of the battery. That's a big difference. That means I can use a fairly small lithium iron phosphate battery in order to run equipment. So for example, this 20 amp hour battery here could run a 100-watt radio for about 7 to 10 hours, 20% transmit, 80% receive on HF sideband. And it's a pretty lightweight battery for running a 100-watt radio at full power output. We'll talk more about that later in the presentation. With respect to memory effect, so there is no memory effect with this particular chemistry. We can charge at 20%, 25%, 50, or 75%. So you can use it for both what's called cyclic as well as standby applications. So cyclic means you charge up the battery, you run the equipment until the battery's output shuts off, and then you recharge it. Standby is like a UPS or telecom application because we don't have that memory effect. We can partial cycle the battery, so we're not experiencing that degradation. And a half cycle, a partial cycle doesn't count as a full cycle. So that's a big advantage, partial cycling, and the fact that we're not dealing with this memory effect that you see on other chemistries, like nickel metal hydride and other chemistries out there on the market, older chemistries. Few percent per year in terms of self-discharge. That's also a very big advantage over a lead acid battery, which if you're to let it sit, you have a lot of issues with a lead acid battery. So on the left-hand side here, this is an example of a 12 amp hour battery. Only about 50% usable if you were to pull about 12 amps out of it. Lithium iron phosphate battery, we're getting nearly 100% usable capacity, which means we can use a smaller battery for the application. We get a lot of questions about the circuit board inside the battery. What is this protection circuit module? What does it do? So it does several functions. It balances and equalizes the cells inside the battery, as well as it provides over voltage, over current, over discharge, as well as short circuit protections. That's all built into that circuit board on the battery. So it's not just cells. Some manufacturers, they may just provide cells that are connected. There's a circuitry integrated in there as well, so that you have those protections built in. This is an example of a typical battery spec sheet that we provide with the batteries. And so what's important here to look at is the internal impedance, less than 100 milliohms. And what's important about that is the fact that as the battery ages, we don't see that internal resistance increasing like a lead acid battery. It tends to stay quite stable across the age of the battery. That means you don't get that voltage drop across that internal resistance as the battery ages. Unlike a lead acid battery, which you'll see as you load the battery quite a bit. We provide you with any kind of parameters that you need if you wanted to build your own charging system as well. So that's available. This is very interesting. This is the discharge curve. This is a 12-volt, 20-amp-hour battery. This is the one right here. If what you'll notice on this curve is it's quite flat across 95% depth of discharge. So if I was to pull power out of this battery, you'll notice it stays above that 13-volt range, and then it drops off around 10 volts. There's the cutoff, which the circuit board is shutting off that output. So all of that capacity is available, meaning again, we can use the very small battery to replace something that's quite large, even up to 100-watt transmission. This is also a curve that shows you the usable capacity versus temperature. So if you take a look on the left-hand side, you'll just notice here for an AGM. AGM means it's another word for an absorbed glass mat battery. It's a sealed lead-acid battery. If you were to pull a 1C discharge on an AGM battery, meaning if you were to pull, for example, if you had a 12-volt, 20-amp-hour battery, you pull 20 amps out of about 30% usable at about -20 Celsius. It's about 14 Fahrenheit. If you are using a lithium iron phosphate, it's more than 80% usable. So this is a big advantage. We're seeing that up in the northern states as well, up in Canada as well, where this performance starts to be pretty dramatic improvements at the really cold temperatures. On the high end, it's also near 100% available as well. Feed rates for AGM, though, at very high temperatures. So that's really important, is that available capacity versus temperature. We get some questions about calculating the runtime based on the power. So if you remember from the test, we've got your power, voltage times the current, we've got our watts, 12-volt, 12-amp-hour battery. It's about 144 watt-hours. So if I was to pull 10 watts out of the battery, about 14 hours in terms of the runtime. But with radio, it's a little different. Okay, so with radio, we transmit at a higher power, we receive at a lower power. Transmit at a higher power, receive at a lower power. We have what's called a weighted average power. So if I'm doing a QRP transmission, if I'm using a QRP radio, so for HF, radios 817, 818, Elecraft KX2, KX3, or the new ICOM 705, a 12-volt, 12-amp-hour battery would get me something about a 40-hour runtime. And that's pretty significant for a battery that weighs maybe about 3 pounds. For a 100-watt transmission, again, this would be, for example, 857, ICOM 7300, any 100-watt radios, 891, 991 from Yaesu. Something like this would get you about 10 to 11 hours of runtime for an HF 20% transmit, 80% receive transmission. So there's quite a bit of usable power out of a lithium iron phosphate battery versus a lead acid battery. And so we're going to use this later in the presentation to review in terms of usable capacity. So we're going to switch gears right now. We're going to talk about some of the projects some of our customers are doing with the batteries. This is Michael Jones, W6GYC. He's out here in Santa Clarita. He's built a Go box with the battery. He's got the 20-amp-hour battery inside of a suitcase with a solar controller. So solar controller looks something like this. And he's built a setup where you can charge the battery using a solar panel, a solar controller, as well as the battery. Now, this controller is required in order to charge up the batteries using solar. The reason being is a solar panel's voltage ends up being quite high, and you need a controller in order to regulate that voltage in order to charge up the batteries. We'll show some more information about that later as we go through the presentation. This is out in Panama City, Florida, N4KGL at the top left, doing field day down there. He's got the Elecraft KX3 radio. It's got a mosquito net down in Florida. If you've been down there in the summer for field day, you got to have a mosquito net. Slim Jim antenna. He's got one of our 15-amp-hour batteries. This is really cool. This is Norwegian station, amateur radio station LA9XGA. This is Summits on the Air SOTA. So I'm sure you may have heard about Summits on the Air. It's a competition where you go to these mountaintops to go activate these these sites. You get some points during this competition. I'm going to read you what he wrote. This soda hike started from my home Ixis Ranch at 0600 UTC, and it took me around 3 hours to get to the summit. The weather today was almost unbelievable with minus 10 degrees and a clear blue sky, and the view from the summit almost indescribable. On this activation, I was using my Elecraft KX3 with 5 to 10 watts of output, 2 Bioenno Power lithium iron phosphate 12 volt 8 amp hour batteries, and a buddy stick multi-band vertical antenna. I made a total of 153 QSOs on this remote summit activation. 153 QSOs, that's a lot of QSOs. And it just gives you an idea of terms of the temperature performance, even up in Norway over there. You got to have your a tent, some skis when you're over there, and at nighttime you build a fire. So it's an interesting application of batteries. I know many of you are interested in solar for powering the batteries while operating. So you can operate your radio equipment using a battery. We talked about this solar controller, and then this controller is used to regulate the voltage from the solar panel. So what you see there is a 60 watt solar panel. This is a foldable solar panel that's also available. This is a 28 watt solar panel. It provides about 1 to 1.5 amps of charge current, and the one that's shown on the screen is what's called a rigid solar panel. That's 60 watts, or you could chain these panels together. So these panels have the ability to be chained together for expanding the power. So you can start with, let's say, for example, if you want to do a portable operation at 28 watts, then you can use larger panels in order to scale up. Now, over there in Michigan, you need a little bit more larger panels to compensate for the overcast days. So we typically suggest something a little bit larger. For example, at least maybe 60 watts to about 120 watts for operating solar over there. But you can still do it throughout the year. So how many watts for the solar panel? So it really depends on the battery. So for example, 12 amp hour battery, 144 watt hours, 60 watt panel would charge it in about 2 hours, assuming you have full sunlight hitting the panel to generate the required power in order to charge it up. So it's pretty proportional with respect to the size of the battery. Do I really need a solar charge controller? I just want to hook it up directly to the battery. So again, it's a must because the voltage from the solar panel actually ranges somewhere between 15 to 22 volts. And so you regulate that voltage in order to charge the battery so that the correct charge current's going in. That is required for the solar controller. This is a very common question that we get. Do I need a special charger for the batteries? So the battery wants to see what's known as a constant voltage current limited power supply. It can be either a linear or a switch mode supply. The overcharge and over voltage protection, that's all built into the battery. So you don't need a special balancing charger. So if you're familiar with quadcopters or radio controlled cars, they use the polymer batteries. There's a balance connector, and you need a special fancy balancing charger. You don't need any of that. You can apply a voltage anywhere between 13.8 to 15 volts, and then current limit the input from the supply in order to charge the battery. Now there's a couple options. We provide with the batteries a power supply that looks something like this. Okay, so this is just a switching supply. It's very simple. Puts out the voltage and the charge current, and we pair it up with the purchase of the batteries. But you do have other options. Okay, so if you guys are using a benchtop supply, there is a West Mountain radio product. This is called Epic Power Gate. You can attach the power supply over here, and then you can plug the battery there. And this product also has the ability to set with these jumpers over here. You can set the chemistry for lithium, and then you can set the amperage as well as control it through a USB interface as well. Over here, you can attach it to a computer and read and set the charge current. Also read out the charge current from the solar panel as well. So you can use a common charging equipment in order to charge the batteries. It's a very common question that we receive. What's the charging voltage? So it charges anywhere between 13.8 volts to 15 volts. And then what's the open circuit voltage after charging? So it's about 13.2 to 13.5 volts. So this voltage matches up with the radio equipment quite well, which wants to see something around 13.8 plus or minus 15%. So you don't need a battery booster with this particular type of battery chemistry. You just plug it directly into the equipment and you can go ahead and use it. So it's one less piece of equipment that you need out there in the field. What size of battery do I need? And how do I know? So we want to look at our total power consumption and desired runtime. Now for a continuous power consumption, I was using 50 watts continuous, 12 amp hour battery, about 3 hours, 20 amp hour battery, 5 hours, 40, about 10 hours, 100 amp hour, 24 hours. Now that's for continuous power. In radio, we have that weighted average. Remember we mentioned earlier, this is very critical for radio. We transmit at a higher power, receive at a lower power. So we can use a smaller battery. And there's a chart that we have, it's located on our website. This is a snapshot of the chart here. It depends on the transmit power that you're at. So for example, for QRP, HF transmission, a 6 amp hour battery, something like this, about 12 hours of runtime. If we're going to, let's say 50 watt VHF, UHF, we're doing work on the repeater, maybe simplex, DMR is between like around 20 watts. This is we have a 12 amp hour battery, puts about 10 hours of runtime. The 9 amp hour battery, somewhere around that range, 12 hours or so on 20 watts, and then 50 watts about 7 hours or so. Now, if we go to 100 watt transmission, we got to use something a little bit larger. We go to the 20 amp hour battery. This is quite popular. This is about 10 hours of runtime at a 100 watt transmission. So it really depends on what you're looking at in terms of your power levels, what kind of transmission you're doing. We can answer questions about that later in the presentation. I'm going to shift gears right now. I'm going to talk about some of our commercial work. Some of the work that we're doing includes Southern California Gas Company and Sempra here in the Los Angeles area. So natural gas out here is typically stored in these massive underground reservoirs in order to buffer for demands. So our state law here requires extensive monitoring for any leaks from these reservoirs. And this is an example of a unit that was installed, what we call a data collection unit. And what you see here is the cylinder right here. This measures the release of any kind of gas. So it measures in terms of the parts per million of gas that might be released. And then this is the data collection unit. It has a built-in ability to measure in terms of that release of the gas, as well as it has a solar controller functionality to charge a 20 amp hour lithium iron phosphate battery. They were using lead acid batteries that they had to change out every year. So they had to send technicians to sites where they couldn't run the power AC mains to. They had to run these battery backup systems that would be charged by solar. So they have these units set up, and we're working with them on additional pilots for this application. So it's an interesting application of batteries. We're going to go up to Canada right now. Let's go to Alberta, Manitoba. This is an example of some of the work that we're doing with nanometrics. This is a very interesting application for oil and gas exploration. So this is a KU band satellite-based telemetry system. So out there, there's no LTE cellular. You don't have the radio packet. The data rate's too low, so they go to satellite to get the bandwidth that's required. And you'll notice they have 4 fairly large panels. This is about 100 watt each, so you're looking at 400 watts a panel because of the short solar day, right? So up there, it's much shorter, so you have to use fairly large panels, and also it's overcast, so you have to compensate for that as well. And they use some of our 20 amp hour batteries and controller system that they built, and it's been quite interesting so far with them. This is the same concept. This is a company called Flow Services in Shreveport, Louisiana, Laredo, Texas. This is a solar-based telemetry system. This is, again, looking at oil and gas flow monitoring. This operates on LTE cellular, and they do use radio packet where places they can't get LTE cellular. They've incorporated our 20 amp hour and 30 amp hour batteries, solar controllers. They replaced the entire SLA AGM batteries with lithium iron phosphate. It's been a lot easier to maintain in terms of the cycle life and the performance. Some of the events we've been to, I think I've seen some of you at Hamvention. We've been going past several years. And there's a lot of West Coast events here where we're at, but hopefully we get to see you guys at some point in Ohio for Hamvention out there if you guys attend, coming down to visit. Hopefully it's going to happen next year. Some other photos of some other events we've been to as well. This is really interesting up here in the corner. You'll notice this is an example of a Go box. This is out of a Pelican case where they put the radio, put the solar controller, as well as the battery, some foam. Take that for emergency preparedness as well. So when the power fails and you want to transmit and need something, building a Go box tends to be a good activity as a club. We really recommend it. We've worked with a lot of clubs in terms of them building Go boxes as well. Same principle, you have the battery and then they choose whatever radio. And then there's some solar component as well in there if needed for charging the batteries out in the field. CQ Magazine, there's been some articles written as well. Certainly take a look at that. And then at QST Magazine, there was an article written about batteries. This is a really neat book. This is Stu Thomas's book about portable operating. Talks about batteries. If you want to have a chance to read that, there's some cool things in there as well. We're in other markets, audio-visual, marine market. So if any of you have if you go fishing, you have trolling motors, fish finders, we're replacing the lead-acid batteries that are used for that market as well, because the trolling motor batteries, the lead-acid ones, can't really keep up, and the fish finders are pulling a lot more power as well. So it's an interesting application. Batteries, robotics, RVs, and campers out there in the field. Some of our other products we have here, some of our power pack products, they have a built-in battery inverter as well as solar controller, so we can use that for in case of power failures, backup systems. We have those available as well. So now here's the door prize. This is the 12-volt 9-amp-hour battery, and then you'll get also the accompanying charger as well, power supply. So this will be the lucky winner. Will get this. This is good for up to 50-watt radios. It's a really popular battery, so you can use this one for that application as well. So when you guys are ready, you guys can send me the information, and we'll open it up to questions. Send it back to Mike.
So that was awesome. I want to thank you so much, Kevin from Bioenno. I do appreciate you coming out and spending the time to share with us all of your knowledge, and I know I absolutely love your batteries, and a lot of other people do. So if you guys have any other questions, go ahead and leave them in the comments. I'll try and answer them as best I can. And until next time, thank you for watching another episode of K8MRD Radio Stuff 73.